Okay, gang, I wanted to give you guys some more help with factoring before tomorrow's quiz and solving while factoring. So we're going to factor first and then do a couple on solving. So we've got some quadratic expressions here and a couple things that we need to mention. You're looking for special patterns. If you don't see any special patterns, you're also looking for greatest common factors that you can take out of here. And so that's what they mean by factoring monomials first in the example here. So if I factor out a 5 from each of these, that means divide each term by 5. 5 comes out x squared minus 4. So the original problem was 5x squared minus 20, but 5 and the 20 both have a factor of 5, so I pull that out, leaving 5 times the quantity of x squared minus 4. So then I could take that and say, alright, well, my x squared minus 4 is a difference of two squares. Square root of x squared is just x. Square root of 4 is 2. X minus 2. X plus 2. And then the 5 out in front. That would be fully factored. Okay? Alright, and then same situation with the next one, 6p squared plus 15p plus 9. I don't see a perfect square trinomial. I don't see a difference of two squares, but I do see a factor of 3 and 6, 15 and 9. So if I take out a factor of 3, so if I take out that, like I said, if I take out that factor of 3, I'm left with 2p squared, 2p squared plus 5p plus 3. So leading coefficient times 3 gives me a 6. That goes on top of our eye chart, positive 6. And we need factors of positive 6 that add up to positive 5, the middle coefficient, the B coefficient, 1 and 6, 2 and 3. Well, because this is positive and this is positive, both our factors have to be positive. So the sums are 7 and 5, and the differences are 5 and 1. But really I'm not going to use these differences because nothing is negative. There's no negative with 6 or 5. So we're going to either use 1 and 6 or 2 and 3. And since 2 and 3 add up to 5, we're going to use 2 and 3. So I start by saying, alright, instead of 2p squared plus 5p plus 3, I now have two sets of parentheses that are going to set up my two factors. And I know I'm using 2 and 3, so 2, 3. And I know they're both positive. Then what I like to do is recopy 2p from the leading term, 2p squared. Notice it's 2p, not 2p squared anymore. Now, the trick is that I look at the two terms in each factor. 2p plus 2. Do they share a common factor? Yes, they do. They share a 2. That 2 then has to disappear and become p plus 1. Okay, and then in the other factor, 2p plus 3, they don't share any factors other than 1, so nothing can really disappear, so 2p plus 3 must be a factor. So the fully factored trinomial is 3 times the quantity of p plus 1 times the quantity of 2p plus 3. So there are actually 3 factors here. Okay, in our next problem, 2u squared plus 8u. I notice there is a 2 and a u in both terms. It's not a difference of two squares because it's addition, and it's not a trinomial, so we can't do factoring like we did in the second problem. So I'm just going to look for a common factor, and I see 2u. Pull that out. What's 2u squared divided by 2u? U. 8u divided by 2u? 4. So we're done. 2u times u plus 4. Two factors. One happens to be a monomial, one happens to be a binomial. 2u's are monomial, one term. Binomial, two terms. Alright, and the last problem here, 4x squared plus 4x minus 4. So we get a common factor, let's take out, is 4. Hopefully you can see that. 4 times the quantity of x squared plus x minus 1. So we have 1 times negative 1 gives me a negative 1. And we need factors of negative 1 that add up to 1. I don't think that's going to happen. Well, maybe. Let's see. No, -1 and -1, they would add up to -2. And +1, -1 would add up to 0. And yeah, so this is not factorable, this trinomial. So then we're done. We factored it. 4 times the quantity of x squared plus x minus 1. Okay, we have two problems here. The first one is x squared plus 3x minus 18 equals 0. So they want us to solve this quadratic by factoring. So again, I'm going to take the leading coefficient of 1 times -18 and get an eye chart for -18. And I'm looking for factors of -18 that add up to 3. 1 and 18, 2 and 9, 3 and 6. 4 doesn't go in, 5 doesn't go in, but 6 does. So I've repeated, so I know I've listed all of my factors of 18. So I need factors of -18 that either add up to 3 or have a difference of 3. So 1 and 18 is 19. I'll block this off. 17, 7, 11 rather. 2 and 9 is 11. Difference is 7. 3 and 6 is 9. Difference is 3. 9, 3. Well, it looks like I'm going to be using 3 and 6 because they have a difference of 3. The question then is the 3 or the 6 going to be negative to make -18? Well, 3 that we're adding up to is positive, so the larger of those two factors has to be positive. So I'm going to take the copy of x in both factors, and then we're going to go -3 plus 6. Because -3 times 6 would give us -18 like we wanted, and 6 and -3 gives us +3, which we also wanted. This is set equal to 0 still. In order to solve for the x values that would work, we're looking for x's. When we plug them in, make this whole thing 0. So we take each factor, set it equal to 0, and we get x equals 3 or x equals -6. What this means is at either spot on the x-axis, at 3 or -6, our y value will equal 0. It also means that's where we're crossing the x-axis, or x-intercept. These are also called zeros, or solutions to a quadratic equation. They're all synonyms. Alright, next problem. 2t squared minus 17t plus 45 equals 3t minus 5. So the first thing we want to do is move everything over to one side. I like to move the side that has the least. So I'm going to add 5 to the right to get rid of the -5. And then I add 5 underneath the 45 on the left. So I have 2t squared minus 17t plus 50. Then I'm going to subtract, and that equals 3t. I'm going to subtract over 3t so that I get rid of the 3t on the right and becomes a 0. So I end up with 2t squared minus 20t plus 50. Well, now we need to factor and solve. I can take out a 2, leaving t squared minus 10t plus 25 equal to 0. And hopefully you can see this 25 is a perfect square. And the square root of that would be 5. 5 times 2 is 10. So we have a perfect square trinomial here. T minus 5, t minus 5 times 2 equals 0. So when you set both factors equal to 0, you get t equals 3. Or excuse me, 5. T equals 5 for both. We would say this has 5 with a multiplicity of 2. But don't worry about the multiplicity part. We're going to talk about that later. Okay, last question. It says find the zeros of the quadratic function. All that means is find the places on the graph where the y value is 0, meaning it crosses the x-axis. So you just are creating a quadratic equation where y is 0, and we do the exact same thing we've been doing. We factor -6, factors that add up to -1, 1 and 6, 2 and 3. 6 and 1 make 7, 2 and 3 make 5, 6 minus 1 makes 5, 3 minus 2 makes 1. So 3 and 2 are what we're looking for, and the bigger one has to be negative since this -1 is negative. Alright, so 0 equals x minus 3, x plus 2. And again, if this had been, say, if the leading coefficient had been, say, 3, I would put 3x minus 3 and 3x plus 2, but it wasn't. And we would have also multiplied 3 times -6 to get this number above our eye chart here, just to make sure you're aware. Okay. So then I set each factor equal to 0. X minus 3 equals 0, x plus 2 equals 0, so x equals -2, and x equals 3 are the zeros of the function, meaning at -2, 0, we'll have a point, and at 3, 0, we'll have a point. And this is where they cross the x-axis. 1, 2, 3, 1, 2. Okay, and that means that our parabola will be crossing there and there. So that means that our vertex is at 1, 2, 3, 4, 5. So at 1, 2, and a half, our axis of symmetry will be going right down what looks like x equals 1/2. Okay? Alright, I hope that helped. Best of luck.